why do we even have a brain? Brains are really expensive, right? That 3-pound blob of meat between your ears is the most metabolically expensive organ you have in your entire body. It requires about 20% of your entire metabolic budget. So that's a lot. To answer that question, we have to go very, very, very far back in time, about 550 million years to a time when the Earth was ruled by creatures who had no brains. Back then, creatures actually didn't need brains. And here's why. Because creatures were tiny, tiny, tiny. There's one particular animal that's still alive today called an amphioxus. It wriggles around in the water, plants itself in the sand like a blade of grass, and then just opens its mouth and filters food. So it's a little bit like a stomach on a stick, and it has no brain. It doesn't need a brain. In the Cambrian period, about 550 million years ago, animals developed something called a lateral line system. They were able to sense with their bodies the vibrations in the water around them. And one creature ate another creature quite deliberately. That is, predators and prey evolved. What you see happening over evolutionary time is that animals' bodies got bigger because more complex motor systems could move faster and with more agility. In order to move nutrients around, you have to have lungs and a circulatory system. As a consequence of this, you've got to have systems that get rid of waste, like your kidneys and your liver. So brains evolved, we think, under the selection pressure of having to coordinate a really, really complicated body. How your brain makes sense of the signals in your body matters, and it matters for the following reason. Predictions are not just about experience, they're about action. It's making a guess about what it has to do next and what the sensory consequences of those motor movements will be, and it's attempting to remember, to re-implement events from the past that are similar to the present.
So in this episode, we're going to learn all about how new memories are formed and also about how to fight back against aging and neurodegenerative disease states like dementia and Alzheimer's disease.
We'll learn how to take scientific evidence and transform them into tools to keep your brain as healthy as possible for as long as possible. This is Brain Health on Masterclass.
As we take this walk in Washington Square Park on this beautiful spring day, the temperature, it's a little bit cold. You hear the sounds of conversation. You smell a wide range of odors. You are activating so much of your brain in this short walk. There's so much stimulation. Look at this tree over here, just so beautiful. That cherry blossom tree. It is a feast for all the senses.
What is perception? Perception is defined by our senses. There's the visual sense. Obviously, we are visual animals. About 30% of the human brain is primarily focused on processing vision, which is a huge proportion. Smell, the olfactory sense, the auditory sense, the taste sense, and the sense of touch.
Everything you see in your brain. Everything you hear in your brain. Of course, you need your eyes and your ears to be able to see and hear, but the actual experience is happening in the brain. Your brain is trapped in a dark, silent box called your skull. For your whole life, your brain is receiving signals from the world and from the body. that these signals are hitting sensory surfaces like the retina in each eye, the cochlea in each ear, all the sensory surfaces on your body, and then there are sensory surfaces inside your body. And these sensory surfaces are constantly sending signals to the brain. Now, these signals are the outcomes of some change. Something's happening in here in the body. Something's happening outside in the world. But the brain doesn't know what's happening. It only knows the outcomes of those events, which are the signals it's receiving. So it's receiving the outcomes, and it has to guess at the causes. Well, what's happening in the body to cause those signals? What's happening in the world to cause those signals? The brain doesn't have access to those causes. This is called an inverse problem or a reverse inference problem, having to guess at the cause of something when you only know the outcome. Now, luckily, the brain has one other source of information that it can draw on, and that is your past experience. It's automatically associating from which parts of the past will be relevant to make sense of the incoming sensory signals. Take a look at this image. Right now, your brain is sifting through thousands of prior events, attempting to answer the question, what is this like? Not what is this, but what is this like? If you're right now seeing black and white blob, then you are in a state of experiential blindness. And now, we will cure you. Take a look at this. Now, when you look at the screen, you probably see a bee, or something like a bee. The thing is, the image hasn't changed. You have. Now, your brain has a new past experience that it can use to help complete the image so that you see a bee where there is no bee present. Everything you experience is some combination of the remembered past and the sensory present. The remembered past is the predictions that your brain is generating. It's anticipating for functioning in the present.
How does memory work? That is what I spent so many years thinking about. What neuroscience can tell us is that there's lots of different kinds and forms of memory. There's motor memory, that memory that we use to learn how to play tennis, or when we put our key into the lock and we know exactly how to jiggle it. The form of memory that most people think of as memory is what neuroscientists call declarative memory, memory for facts and events. Trying to understand how that happens, where that happens. You get to Neuroanatomy 101. The human brain is made up of the cortex. That's that outer covering that is all wrinkled. The brainstem, that is where all the sensory and motor information is entering and exiting. And the cerebellum, important for fine motor movements. We can't walk properly without the cerebellum. That cortex is made up of 4 major lobes. The first one, right behind your forehead, is called the frontal lobe, critical for personality, for focus, attention, and decision-making. Just behind the frontal lobe, the parietal lobe, critical for our ability to process the spatial layout of our world. The back of the head is called the occipital lobe, that primary visual cortex. That is critical for vision. And finally, my favorite lobe is called the temporal lobe, just behind the temple here. And that houses my favorite brain structure called the hippocampus. You have one on the right and one on the left. Hippocampus means seahorse. It actually has this curlicue structure of a seahorse. The hippocampus is absolutely critical for any new information to get into long-term memory. People don't realize how bad our own human memory is. Our memories can be corrupted. We can remember the wrong thing. Many fights you might have had might be over, the veracity of your memory versus your husband's or your wife's or your brother's or your sister's memory. We are not our computers, and I don't know if I want to be.
If you're like me, you probably lose your keys or you've misplaced where your wallet is. If you put me up against a chimpanzee would win every time. The chimpanzee would know where the keys are. The chimpanzee would know where the wallet is. Chimpanzees have amazing memories for details, specifically for finding items in large expanses because they have to forage for food.
People always ask me, how can I improve my memory? I want to be smarter. I want to remember more. I want to be better at my work. And the good news is we have some clear things that every single person can do today to make that happen. Powerful ways to strengthen your memory. Repetition is good. The more times you repeat it, the more times the hippocampus can help encode that memory. Repeat them over and over. Associations are really helpful for your memory. So if you know a friend of this new person that you're just meeting for the first time, you remember that person better. So if you can associate things, it's better for your memory. Novelty is good for your memory. If it's the same old person, same old situation, you don't tend to remember it. Our brains are focused on that novel thing that happens because it could be dangerous or important. So focus on what is novel, and that helps strengthen that memory. And fourth, emotional resonance. Because the hippocampus is connected very strongly to a structure called the amygdala, important for processing emotional information. And those happy and sad jolts help encode those long-term memories. So think about all those emotions that are associated with that memory that you are bringing up, and it will make that memory stronger. One of the most interesting things about the human brain is that it's the only structure that we know that can truly think about itself. Consciousness is an elusive state. It's the state of being aware of ourselves and our environment and our feelings and our sensations. We know we have it, but it's very hard to study at a neuroscientific level.
This is the moment in an interview where you expect a neuroscientist to mention something about discovering the basis of consciousness or something, right? Yeah, I'm not going to say that. All I can say, this is what I will say. There's so much that we don't know. There's really so much that we don't know. How does 3 pounds of meat between your ears, bathed in chemicals, sparking with electricity, how does that create your personality and make you who you are?
I think about the relationship between consciousness and memory. Your memory defines your own personal history. It defines who you are as a person. Would you be the same if you didn't have your experiences that you had? The answer is no. Losing your memory makes you realize how precious that memory is. What I hear from people that scares them the most is neurodegenerative disease states. The most common is dementia. Dementia is any situation where you're not able to perform cognitively as well as you were when you were younger. That happens commonly. We've seen our loved ones not be able to remember us, which is, I don't know whether it's more disturbing for us or for them. My father passed away with Alzheimer's disease. I always remember my father worried that he would forget the name of his granddaughter. Alzheimer's disease is the most common form of dementia. It's a disease that we believe has multiple different causes. But always starts with damage of the hippocampal system with those plaques and tangles that you might have heard of. Which is why early forms of Alzheimer's disease are always associated with memory impairment. It then spreads out to the cortex, and that is when you start to see higher levels of dementia. They can't remember how to do things that they've done, and people start to make illogical connections in their brain. This is scary for somebody that it might be experiencing it. It's scary for somebody that is looking at it and wanting to help. And it eventually affects the brainstem, those brain areas that help us continue breathing and help our heart rate continue beating. And that's what kills people with Alzheimer's disease. The good news is that neuroscience tells us what we can do today to protect our brains from neurodegenerative disease states and normal aging. I love the studies that show sleep is so important. Why is sleep so important for your brain? Let me emphasize two things. Number one, when you get good sleep, you are strengthening the memories that you made every single day. Okay, so bad sleep, you're not going to remember what you experienced the day before. Good sleep, you're going to start to put that into long-term memory. So bad sleep, everybody experienced this. I can't remember. It's all a fuzz. It's because sleep is when memories are consolidated. Number two, every single night that you get good sleep is the time when neurotoxins are being cleaned out of every cell in your brain. Get only 3 hours of sleep, you only get a little bit of those toxins and they start to build up. Do that over months and months and years, and guess what? You're gonna have a clogged up, dirty brain. It's hard to change your sleep pattern. It can be done. It's harder because our lives are so busy.
I think I probably spent the first 15 years of my daughter's life sleep deprived because I would be back in my office at 8 o'clock at night. I was working for as long as I could stay up, almost every single day as I'm writing about how bad it is to, to not get enough sleep. Now I get off my computer usually by 9 o'clock at night, and then I will do something like have a bath or do yoga or something relaxing before bed. People are worried about how will they know what's the normal decreases in memory that happen with aging versus something that's a little pernicious.
If you're wondering, is this normal memory loss? Go to the neurologist. Let's say you have somebody in your family diagnosed with dementia. What are those things that will add to cognitive decline, that will make that decline even faster? Well, what I'm going to say should be very familiar. Sedentary behavior. Very bad for cognitive decline. Why? Because the two brain areas most susceptible to aging and dementia and Alzheimer's are the hippocampus and the prefrontal cortex. Every single time you move your body, you are making both of these areas work better, releasing a whole, what I like to call, bubble bath of neurochemicals in your brain, including dopamine, serotonin, noradrenaline, and your focus and attention gets better. With long-term exercise, you're not solving the mystery of Alzheimer's disease, but you get immediate brain benefits. Hearing loss. Why is hearing loss related? Because hearing loss will cut you off from your social connections, and that can isolate you, and that will lead to faster cognitive decline. Unhealthy diets that don't have a lot of fruits and vegetables. What's good for your body is good for your brain.
I'm in Callustians, New York, one of my favorite places, one of the best spice stores in the world. And you may not see exactly the same thing in your supermarket because supermarkets are actually designed to hijack your brain. When you walk into the supermarket, you don't necessarily face healthy ingredients front and center. So I want you to be smarter when you go to the supermarket and think about using the perimeter. Go to the produce aisle first, pick out those fresh vegetables, the berries, all great for your brain health. The aisle that you should go to are the ones with the dried legumes, dried lentils, canned chickpeas, canned black beans, ground spices. And these are great foods that will help your brain. To me, this is like a spice pharmacy. And I'm off to find turmeric. Ah, I see it right here. You can't beat that bright yellow color. Now, you know, the curcumin in turmeric actually is a super brain healthy ingredient for things like cognition and memory. Many people are worried about cognitive health, particularly memory. For some people that I see in my clinic, it could be, you know, family history of Alzheimer's. And when people understand that food can have such a powerful impact on our brain health, they want to learn more and they want to do more.
Today we are making eggs and greens. It starts with a huge amount of nutrient-dense leafy greens simmered in a bunch of really flavorful and really good for you aromatics, topped with some eggs, throw it in the oven. It's ready in just a few minutes.
I love the fact, Gregory, that you're using leafy greens because, you know, the leafy greens are rich in vitamin B9, which is folate. And folate, I like to say the B vitamins are really brain vitamins. Plus, you have this beautiful color of the rainbow vegetables and peppers on your counter there. The plant polyphenols in those foods actually add to the plethora of the nutrients you're adding to the food.
Today we're using collard greens, which I love, kale, which is so accessible, and Swiss chard.
The different types of vegetables all bring biodiversity to your gut microbes, all of which is important.
So we have a warm pan. I'm going to use some extra virgin olive oil. We are going to get our aromatics going. We have this beautiful array of garlic and ginger.
I love the aroma.
I'm going to just chop chili that I'm going to just sprinkle on top.
And so how long do you cook the aromatics for?
Just until they're fragrant.
Right.
I like to season as I go, so
Yes.
we're adding
Every layer.
a
Yeah.
nice layer of salt. We're just gonna wilt these really quickly. We're gonna fold in those beautiful aromatics. You know, it's turning that gorgeous bright green that we love. And now we'll crack our eggs.
The eggs are rich in choline, and choline is excellent for your brain health.
So I'm just gonna season our eggs with a little bit of that beautiful sea salt, and we'll just get this in the oven for 7 to 11 minutes,
Wow.
just until the eggs are soft and runny.
Jeff, I love that you made eggs, but not everyone eats eggs. So I'm making a version using tofu. You can pretty much break up the tofu, right, and make it almost like a scramble. Or you can use a little small blender and blitz it. And you can do this while your greens are cooking. Not too much. So what I'm going to do is add turmeric to my tofu. And then I'm going to put that pinch of black pepper because the piperine in black pepper will activate the curcumin and make it more bioavailable to the brain and the body.
Incredible.
Easy hack. So
Incredible.
anytime you use turmeric, just add a pinch of black pepper. And just adding these in whatever dish you're cooking, and you don't need much, you know, 1/4 to 1/2 teaspoon a day, added to a soup, a smoothie, a beverage is one way to bring that into your life.
a number of years ago, we ran a very large-scale study, and we had a fairly decent number of people who were over the age of 65 and whose memory performance looked like they belonged in the 25-year-old group. And we were like, what? These superagers not only had, very healthful memories, they had very healthful looking brains. They were indistinguishable from the young people. What are these superagers doing differently? What I can tell you is this. The thing that these folks seem to have in common is that they are constantly engaging in challenging activities. Some of them compete in sports competitively. Others decided to learn piano or to learn to paint, or have decided to become master gardeners. They're doing hard stuff that doesn't always feel really good in the moment, and so their brains have to learn to adapt and flexibly bring that regulation back in line. Feeling bad doesn't necessarily mean something is wrong. And it doesn't mean that you should stop working really hard. It means you should get a drink of water, have a snack, get a hug, and get back to it,
No matter what age you are, we are able to shift the anatomy, physiology, and function of the brain.
The brain can continue to wire itself throughout your entire life.
Physical activity stimulates the growth of brand new brain cells.
We're social animals.
Food can really bring people together.
How many social connections you have can predict how long your life is going to be.
We are the caretakers of each other's nervous systems.